Hello, good afternoon everyone. Now my first video will start with mechanical analysis of soils. This is in chapter 2 and we are already in chapter 4, supposedly. But I think this needs some explanation. Then mechanical analysis of soil will be about analyzing the soil, especially its sizes. Mechanical analysis is composed of two methods or two parts. Now, two methods and two parts because we can make use of these two methods one after the other. Okay. Maingon ka og two methods without one after the other, maingon lang kag two methods. But when you say two methods and two parts, meaning you use one method in one part, the other method in the second part. Okay? Oh, when you use the mechanical analysis, the first analysis that we are to perform is the sieve analysis. This is in Bisaya, mag-ayag ka. And then the second one is with the use of the hydrometer analysis. That is using that apparatus wherein you are going to determine specific gravity. In sieve analysis of soil, we have a formula that we can make use of, which is more of a general formula. You have a percent finer than a given size is equal to 100 minus mass of soil passing a given sieve divided by total mass of soil times 100. So this percent finer will be about your sieve size. Then kani is in percent. This is the 100% of your mass of soil. 100%. If for example you have a 100 gram, then that original 100 gram will be 100%. Then it could be containing sand, salt, and clay. So this is a formula that we can determine how much is the percent of sand, how much is the percent of salt, and how much is the percent of clay. Now actually in the percent of clay, it's more on the hydrometer analysis. So if we talk about percent finer of a sieve number, passing a sieve number, so we'll have to have, or we'll have to study the I will introduce you first to the sieves. So, okay, we are going to have the sieves. Okay, so this is the US standard sieve sizes. The table. You have from 4 to 5, 6, and so on. One digit number for sieve number of the number of sieve, then the 2 digits up to a 3-digit number for the sieve number. Now, the larger the number, the smaller the diameter. The smaller the number of the sieve, the bigger the diameter. Okay, so mao nang usual na to nga sizing, no? In for example, sa ato bitong bugas, mais, dagko nga sizes 16, 18, pino. Gagmay galig na gagmay na gig number, dagko. Okay, so mausad ni ang nahitabo. Now the openings are in mm. We can also have the conversion of this in inches. But because we are using now mostly units in SI, so mm. At this is easy to convert to inches. With the same sieve number, inches lang ang opening. Now the opening here is, because that is ayag, you will be using more or less like a wire, screen wire. So the opening would be a square. But this opening mentioned here is the diameter of the square. Okay, so for example, this one here is kaning atong screen nga puti or kaning akong slide. We will have, this is a rectangle. Let's just imagine that this is a square. So instead of having the dimension of that as the diameter or the dimension of that, or the longest, the longest distance from a corner to the opposite corner, we cannot make it as a diameter. So it is better to imagine a circle made here inside this square than take the diameter that way or that way. So that is the opening in mm. Okay, number 4 is 4.75 mm. Maingon tagdako na siya, no? So it's just 4 mm. Just imagine, ang 1 inch is 25.4 mm. So this number 4 is very small, but just imagine the 200 sieve or the 270 number sieve. But 0.053, you cannot measure this using your ruler with the mm. This is an mm, so this is just a portion of your 1 mm. Now this is very fine. Now in our set of sieves, in our laboratories as 80, you can see, I think, the number 4, the number 8, number 10, number 20, 30, 40, 80, 100, 200, or maybe we can have the 60. No. Now we cannot have all of this in our collection because that is very expensive. But it still will enable us to plot the particle size distribution curve even if we don't have the other sieve numbers. We don't have those sieves. Okay. So going back, in sieve analysis, you have percent finer than a given size equal to 100. This is the formula, no? Now, what is this? For example, you'll have you'll have number 4 sieve. So, you will place here percent finer, meaning you are solving for the percent finer than a given size. So, what does that mean? Percent finer could be having another term, or you can use another term for percent finer. The other term for percent finer is percent passing. So, percentage nga ni pass than a given size. What is that than a given size? This represents the sieve. So, percent finer, let's just say number 4 sieve. So, percent passing, number 4 sieve. So, pwede rag atong ilisan. In the formula, we'll have to have the percent finer of a certain type of sieve than 100. 100 is what? That is 100% of your soil. Let's say you have a 100 gram, as I have said, no? Could be containing sand, salt, and clay. But the total weight of it, all of it in its original weight, that's 100%. Then ayag nimo, some of it will pass through, some of it will be retained in the sieve. Kadong ni pass through inyo tong i-weigh, you have to weigh that, then divide that with the original weight or original mass of your soil. So, this one will be a decimal or a ratio, a result of a ratio. You subtract this could be lesser because this is only a portion of the total that passed through. Kung mulusot tanan, di 100 minus 100 passing, 0 times 100. Di nila na, kani pulusot man, you can have the 100% passing if tanan ang nilusot. Pero dili gali tanan ang nilusot, so katong nilusot, you weigh that, then divide that by the total weight of the original, subtract that with the 100, or by the way, you multiply that with the 100, then subtract that with the 100. That is why it's percent, because this one is gram per gram divided by gram times 100. Cancel man tong gram, no? That is in percent. Percent subtracted from 100%, that is why you have a percent passing than a given sieve. So, percent passing in number 4. Number 4. Og nilusot tanan, 100%. Og wala mo lusot tanan, katong nilusot, imo tong i-weigh divided by the total original mass of soil. Then times 100 minus 100%. So that would be your percent finer in number 4. If, for example, this is number tensive, so percent finer or percent passing in number tensive equals 100 minus katong nilusot divided by the total mass of your soil, itong original, times 100, subtract minus 100%, so that would be the percent passing in number 10. Did I say 10, no? 10 sieve, number 10 sieve. So that is how you determine the percent finer or percent passing in a given sieve, in a given size. Okay, this is more of a general formula. Formula raman na siya. You have to have this. You have to perform this. In the performance, mo ni siya ang step-by-step procedure in the determination of percent finer of soil. So, this is in the lab. More or less, you can have this followed when you do. You follow that when you do it in the laboratory. Now, what is said here is small size sieve that should be used for this type of test is the US number 200. Okay. Then, after you have the percent finer and you have known the sieve number that you use or the sieves and their respective sieve number, you know, you can have from the table the diameter, you can plot and plot. You can do the plotting wherein the diameter and the percent passing will be plotted against each other, and the result would be the particle size distribution curve. So, mao na ang resulta, particle size distribution curve, which could be or which could look like this. So, you have here particle size in the abscissa. This is in mm and this is logarithmic. Okay, you have 10, 1.1 in powers of 10. Okay, then from 10 to 1, the middle is supposed to be here, but 5 is not in the middle, not midway of 10 and 1. So, it's more of, it's nearer to 10. So, that is what is happening or what happens when you have the log scale. The greater the number, it goes nearer to the greater number of it. So you have 5 is greater than 1, but it's not in the middle. It is more on or going more to the number greater than itself. So going to number 10. So actually this is not the 0.5 or the 5. Same with 1 and 0.1. So the 0.5 is here. Supposedly you can have it, if it is linear, you can have the 0.5 here. Okay. Then you have the percent finer on this side. You always start with 0% to 100%. Of course, you have the 0 at the intersection of the ordinate and the abscissa, then going up. But in here, or in this side here, you have the 10, and take note that is decreasing in size, decreasing in number and the calibration. You have the 10 mm, the 5, so the opening is decreasing up to the 0.05. Nagkagamay siya. Okay. Other graphing paper, this is bali siya. It is more of a bali. Others started here with the smallest diameter, then increasing to the right to the maximum diameter available. Okay. So, if you have a greater number at the intersection, in decreasing at this point here, you will have a result of the curve like this. Pero if you will have a smaller diameter on this side, greater diameter on this side, you have the opposite of this curve. So, you will have a plotting like that. So, this one will be here, dira, ana. So, ana. Because if you can If you only have a copy of our manual, it is opposite. We'll start with the smaller and bigger on this side.